This is the Lockheed Martin SR-72, an aircraft so fast it can cross oceans before the enemy even blinks.
This is the Lockheed Martin Senior 72, an aircraft so fast it can cross oceans before the enemy even blinks. First appearing in Top Gun Maverick and nicknamed the Son of the Blackbird, it's the hypersonic successor to the legendary SR-71 Blackbird. But what makes this aircraft so terrifyingly advanced, and why are rival nations like China and Russia scrambling to catch up? The United States government doesn't like to show its technological advancements in front of the whole world until it's too late for anyone to do anything about it, so we would assume that the work on SR-72 Darkstar began way before it appeared in the movie. To be successful, the SR-72 Darkstar had to meet three specific objectives: 1. Travel at speeds higher than or equal to Mach 6, 2. Travel above 880,000 feet for extended periods of time, and 3. Stay completely hidden from advanced tracking and radar systems. In order to achieve this, Lockheed Martin not only had to have a completely redesigned aircraft but also build a new engine and tackled the associated challenges of traveling at speeds 6 times the speed of sound. Like surface and cockpit heating, reports indicate that Lockheed Martin had been working with Aerojet Rocketdyne since 2006 to build an engine that could propel an aircraft to Mach 6 using scramjet technology. The scramjet engine uses fast-moving air to first compress and then combust. However, scramjets only provide good performance above Mach 2.5, therefore the SR-72 had to use another engine type at lower speeds. It was reported that, like the SR-71, the SR-72 would also be fitted with a turbine-based combined cycle engine to be able to switch between turbine and scramjet engines as needed. This system would be fed a shared inflow of air through the nozzle, but with individual airflow paths. To fully experiment with this system's feasibility with the SR-72, NASA allowed Lockheed Martin to study the existing turbine propulsion systems with a contract worth $892,000 in December of 2014. At such high speeds, the material used for the body construction would also have to be superior to that of its closest match, the SR-71. Data from SR-71 flights indicate that the surface temperature of the aircraft reached higher than 500 degrees Celsius in flight at speeds greater than Mach 2.5. This temperature would be sufficient to melt any conventional aircraft building materials. Needless to say, the SR-72 Darkstar would have to use lightweight materials in its construction which are capable of tolerating extreme temperatures and shear stress of Mach 6. Ceramic, titanium alloys and metal mixes would likely be chosen for this purpose, as they have been used in space shuttles flying above Mach 20. Another variable that comes into play is the few rumors of the SR-72 being unmanned, which was dismissed by the project leader of the SR-72 program, Brian Herberger, in a hint that he dropped when being interviewed by the YouTuber Sam EOLM about the Darkstar's ability to fly unmanned, claiming it had the capability of doing both based and mission requirements. Now, of course, speed is everything when it comes to hypersonic spycraft like the SR-72, but it has to have the ability to drop bombs and strike targets to be able to fully utilize these capabilities. Any normal bomb would simply be unstable at hypersonic speeds, and Lockheed Martin announced in 2018 that the SR-72 would be fitted with hypersonic missiles and be able to take its first flight in 2025. While starting active duty as soon as 2030. But why is the SR-72 Darkstar coming nearly 30 years later than the SR-71 Blackbird? The prototype used in this film was a result of a joint venture of Lockheed Martin Skunk Works division and Paramount Pictures designers. This is the same Skunk Works division that worked on and finalized the design of the SR-71 Blackbird back in the 1950s. The final model of the Darkstar, designed by Daniel Simon after many iterations later displayed in the same movie, was so realistic that Chinese intelligence agencies reportedly started conducting satellite surveys, further investigating the reality of the SR-72. In part with its similarities with the mock-up listed on Lock's website, wouldn't that seem like too much attention to a science fiction film? Well, given the idea that the SR-71 Blackbird exists and holds the world record for the fastest manned aircraft, which still scares many foes of the United States, the concept of its new generation will surely turn heads and roll eyes, serving as a reminder of how close fiction is to reality in today's world. Even so, is the SR-72 Darkstar concept different from the SR-71 Blackbird? Lockheed Martin designed and built the SR-71 Blackbird in the 1960s, and since then it has held itself up as the fastest manned air-breathing aircraft in the world, going up to Mach 3.2 high supersonic speeds at the time, which has still been difficult to beat for adversaries even with today's technology. Even though some aircraft can reach that speed, none can cruise at this speed for long. But why was it needed? Well, in simple words, the US had to have eyes on its enemies without them even knowing. It was there, but with advancements in radar and tracking technology, the US had to go hypersonic to understand why the SR-72 Darkstar had to be developed. We have to know hypersonics and their role in modern warfare. Hypersonic jets and missiles are already here and constantly being worked on by Russia and China. The race for advanced arms has just begun, and understandably the United States wouldn't want to be left out in the blue. Usually anything that goes more than Mach 5 is considered to be hypersonic, and with modern defense systems the SR-71 simply couldn't keep up with the tech advancements, which is a big reason why it was retired from service in 1998. So Lockheed Martin's Senior 72 Darkstar program had to be surfaced, and we recently saw its concept being publicly acknowledged. Even though it was just an idea from a movie, it was taken seriously enough by us rivals around the world to start gathering data about this new aircraft, showcasing the gravity of the US's arms capability and its effects on the world. What exactly does Senior 72 have that makes it so blatantly threatening to us rivals? Well, the SR-72 program has seen multiple development challenges, and the technology needed to propel an aircraft 6 times the speed of sound is simply too complex to be implemented easily. In November 2013, the U.S. Air Force Chief of Staff General Mark Welsh stated that the service needed a hypersonic aircraft that would significantly reduce the reaction time for any adversary, and that the Air Force was interested in regaining its hypersonic superiority. By December 2013, this statement changed, and the Air Force declined to fund the SR-72 program, claiming it had never reached out to Lockheed Martin for the SR-72, pressed by budget cuts and other factors. The U.S. military chose to develop the Northrop Grumman RQ-10 unmanned aerial vehicle to conduct its intelligence, surveillance and reconnaissance or ISR missions, as it was much cheaper and less complex than the SR-72 program, but still kept so confidential that not a single image exists of the RQ-10 UAV. Work on the SR-72 was then carried out in complete confidentiality until 2015, when NASA awarded the contract to study dual-mode engines to achieve speeds greater than Mach 6 and envisioned the State Route 72 as the perfect ISR and strike platform. By 2017, Lockheed Martin had a complete RD of the SR-72 Darkstar, claiming it could get started on development by the early 2020s. In 2018, Lockheed Vice President Jack Onan further entailed the integration of modern technologies in the SR-772 Darker program, like computer modeling and 3D printing, which could potentially solve the problems that would have made it impossible to build an SR-72 in the last 5 years. It goes without saying that there was absolutely no public information about the SR-72 program, and officially it just didn't exist until it got renewed public interest after its appearance in Top Gun Maverick. Complete secrecy was and still is the key that has enabled the US government to innovate and shock the world with its superiority in arms and capability. But what about the current status of the program, and what's at stake for the United States? Currently there have been no documented flights or tests of the SR-72, but it is likely because of the confidentiality of the program. For all we know, the aircraft could be in the initial production stage or test flights. However, the hints being dropped by Lockheed Martin now and then suggests that the US has never been out of its #1 spot in the hypersonic weapons industry. With significant improvements in the US military's technological capabilities, they race to own a hypersonic aircraft capable of penetrating enemy airspace at high speeds and completing ISR and strike missions, and the US's global position. Russia and China are most likely to take a competitive stance with their own versions of hypersonic jets. Throughout the past, there have been multiple hypersonic weapons and nukes that most defense systems have gotten used to employing anti-air surveillance systems and high-speed tracking systems, making them less effective. The basic principle that can single-handedly defeat these systems is speed, and lots of it, and the SR-72 does exactly that. At Mach 6 it can travel thousands of kilometers within seconds, giving its enemies a fraction of the time to react or even acknowledge its presence. And one thing we can be sure of is the United States being the only capable country in the world of operating this aircraft due to its fearless and effective strategies. Whether good or bad, only time will tell, but SR-72 and projects like it are perhaps the future of hypersonic warfare. Lockheed specialists used an easily machined titanium alloy that softens at a lower temperature, but the high temperatures that arise during flight at speeds of several Mach required a special approach to the design and operation of the device. For example, the main sections of the SR-71 skin were corrugated rather than smooth, causing aerodynamicists to jokingly call the Blackbird the Mach 3 Ford Trioteur due to the latter's peculiar corrugated aluminum skin. But this was quite reasonable for a new aircraft, since high temperatures would simply lead to splitting or twisting of the smooth skin, while the corrugated skin could expand vertically and horizontally, having increased longitudinal strength. The fuselage panels were made to fit loosely against the aircraft on the ground, and proper alignment was achieved as the SR-71's body heated up with thermal expansion of several inches. The outer windshield of the cabin was made of 3 layers of glass with cooling sections between them and ANS navigation window. It was made of solid quartz ultrasonically welded to a titanium frame, thanks to which even the heating of the outer part of the windshield to 600 degrees Fahrenheit during the mission was of no concern to the aircraft. The SR-71 was designed with the sole focus of being undetectable on enemy radar. This effort had even gone so far as to use cesium-based fuel additives to reduce the radar visibility of exhaust plumes. However, even this legendary colossus fell victim to its high cost. At least it was this reason that became one of the cornerstones in Congress's decision to stop operating this reconnaissance aircraft in 1989. The U.S. Air Force finally retired the SR-71 aircraft in 1998. Although NASA operated the last 2 airworthy aircraft until 1999, after which they took their rightful place in museums. As the years passed, the question of a hypersonic successor to the Blackbird became more and more pressing. The task was not an easy one because, according to some sources, over the years of service, the SR-71 managed to outrun more than 4,000 missiles fired at it, operating with virtual impunity, even in the most hostile airspaces. It's believed that the first rumors about the SR-72 appeared in 2007, but it had in fact happened in the very early 2000s when Skunk Works realized that the era of the SR-71 had come to an end and the time had come to prepare a worthy replacement for it. The years 2006 to 2007 are mainly relevant in that Lockheed engineers together with the Aerojet Rocketdyne team had been working on an engine capable of hypersonic speed since this time. Aerojet Rocketdyne applied their scramjet technology, supersonic combustion ramjet, to the engine design of the future SR-72. Since it was supposed to receive advanced air-breathing propulsion system, which would be able to work equally well not only at subsonic and transonic, but also at supersonic and even hypersonic speeds. After all, the assumption is that a turbojet performs well from 0 to Mach 2.2, while ramjets are poorly applicable at speeds below Mach 0.5 but demonstrate amazing performance at speeds from Mach 3 to 6. That is, the ideal solution for Son of Blackbird was a turbine-based combined cycle TBCC system with a turbine engine for acceleration and landing of the aircraft and a scramjet for high speeds. Moreover, the inlet and nozzle of the engines would have a common placement but with separate airflow paths. As with the SR-71, the issue of materials in the SR-72 became an issue because aircraft traveling at speeds of Mach 5 and above are subject to extreme temperatures sufficient to melt a standard metal airframe. By comparison, a steel hull would begin to melt after reaching temperatures of 2,500 degrees Fahrenheit, while the SR-72's fuselage would need to withstand temperatures of 3,500 degrees Fahrenheit and even higher to survive. So engineers faced the daunting task of making critical components from composites like the high-performance carbon, ceramic, and metal mixtures used in intercontinental ballistic missiles and retired space shuttles. In 2013, Lockheed Martin Skunk Works finally officially confirmed the development of the SR-72 on Lockheed Martin's website, saying it would fly twice as fast as its ancestor, that is at speeds up to Mach 6. The team supported such a bold statement by saying that the SR-71 was developed using 20th-century technology using slide rules and paper, emphasizing that it was not controlled by millions of lines of program code and did not run on computer chips. But the SR-72 would be a beast of a completely different generation. UAV. The main task for Skunk Works engineers, as expected, was the development of engines for the future drone. After all, it had to cover several flight modes at once: subsonic, supersonic and hypersonic, to achieve design speeds. By the time of publication in 2013, the team had already been working closely with Aerojet Rocketdyne for more than 7 years to develop a method for integrating a ready-made turbine with a hypersonic ramjet engine scramjet to propel the aircraft from standstill to those cherish speeds of Mach 6 and higher. The future drone's engine began with a conventional Pratt & Whitney F100 and General Electric F110 turbofan engine as the basis. This helped the device take off from a standstill and accelerate to supersonic speeds like a regular fighter, but as soon as the figure got to about Mach 3, the second part of the came into play. It's rumored to be a dual-mode ramjet engine that uses the enormous pressure of incoming air at supersonic speeds and a variable air intake designed to create deliberately directed shock waves for compression. As a result, such a solution will help the aircraft not only surpass its legendary ancestor Blackbird but also move even higher than the hypersonic barrier of Mach 5 set for the Skunk Works team. The second challenge for Son of Blackbird will almost certainly be extreme temperatures. Therefore, specialists will have to make sure that the insane speed coupled with the heat doesn't turn the glider into hot jelly. The team will definitely benefit from using composites, high-performance mixtures of carbon, ceramics and metals in its design, especially for critical UAV components. For comparison, a typical steel hull will begin to melt at 2,500 degrees Fahrenheit, while the SR-72 will need to withstand at temperatures of 300 degrees Fahrenheit or higher to survive successfully. After the United States became the world leader in hypersonic technology thanks to NASA's X-43 and Boeing's X-51 programs, it shifted its focus from these advanced systems to combating the global terror threat. For several decades, in 2017, Lockheed Martin Executive Vice President and Skunk Works CEO Rob Weiss told the media that hypersonic propulsion testing for the SR-72 had been completed and the team was now approaching the start of work on the SR-72 flight research vehicle FV, a technology prototype the size of an F-22 Raptor, about 60 feet, with a single engine capable of flying at Mach 6 for several minutes. Just 1 year later, Lockheed Vice President Jack O'Banion shed a little more light on the company's achievements in the field of additive manufacturing and computer modeling, saying that building such a device in the early 2010s would have been simply impossible, and 3D printing allowed the company to even integrate the system cooling to the engine. In March of 2018, the Russian president announced the start of an unofficial hypersonic arms race, introducing the X-47M2 Kenzel hypersonic missiles. After this, even mention of the SR-772 program disappeared from the official Lockheed Martin resources. It's as if all the efforts in partnership with Aerojet Rocketdyne were put on hold. However, representatives from Lockheed and the US Air Force have repeatedly mentioned the use of new hypersonic vehicles, including the SR-72, as hypersonic missile launch platforms. While releasing or launching hypersonic missiles in high-speed flight poses a string of engineering challenges due to the enormous pressure and heat, Lockheed Martin has already proven the viability of successfully launching air-to-air missiles at speeds greater than Mach 3 using YF-12 prototype interceptors. At a certain point, the SR-72 seemingly died out as far as the public eye was concerned, but in 2021, Air Force's Profession of Arms Center of Excellence released a video of a single-engine flight research aircraft that closely resembles renderings previously shown by Lockheed, and just a year later the sequel to the acclaimed film Top Gun Maverick was released in cinemas, where viewers were shown a certain Darkstar, a hypersonic aircraft created by none other than the Skunk Works engineers, and apparently they succeeded in making it look like a real aircraft. It's unlikely that the filmmakers managed to accelerate to Mach 10, but the film's producer either jokingly or seriously stated that the US Navy noted the Chinese satellite's interest in the device. To do this, he even had to change his route to photograph Darkstar, although who knows, maybe the PRC military just has American film fans among their ranks one way or another. In recent interviews, the first flight of the SR-72 prototype was scheduled for 2025, and the aircraft itself may enter service as early as 2030, considering that in the early 1930s the US Air Force planned to introduce the 6th-generation NAD fighter into service. One can only hope that the budget will withstand the pressure from two iron birds at once, coupled with the new B-21 Raider bombers and hundreds of collaborative combat aircraft drones, these being developed as future representatives of the US Air Force fleet. What do you think? Will the successor to the SR-71 Blackbird emerge from the shadows by the 2030s, or are we not destined to see the latest UAV until 2040?